When installing an antenna mast, several factors determine the appropriate support method. In this case, a 1.25-inch rigid mast extends 3 feet above the roof, positioned 6 inches from the roof's edge. The local electrical inspector initially approved the installation without a guy wire, citing compliance with the National Electrical Code and local authority having jurisdiction. However, the utility company, often referred to as POCO, has overruled this decision, mandating the use of a guy wire for connection. This situation highlights the potential conflict between code compliance and utility company requirements. POCO's decision likely stems from their own safety standards and liability concerns related to the stability and potential hazards associated with unsupported masts. The ANSI/GI 222G standard, a widely recognized industry benchmark for antenna installations, recommends guy wires for masts exceeding 3 feet above the roofline and located 6 inches or more from the roof edge. This standard reflects the increased risk of instability due to wind loading and the mast's leverage. Considering safety, a guy wire provides crucial additional support, especially in areas prone to high winds or severe weather. It significantly reduces the risk of the mast collapsing or swaying, which could damage the antenna, the roof structure, or nearby property. Structural integrity is another critical factor. A 1.25-inch rigid mast may not possess sufficient strength to withstand the combined weight of the antenna and the forces exerted by wind, particularly when mounted 3 feet above the roof and only 6 inches from the edge. The leverage created by this configuration amplifies the stress on the mast and its mounting point. Liability also becomes a concern. If the mast fails due to inadequate support, both the installer and the homeowner could face legal repercussions for any resulting damage or injuries. While the National Electrical Code does not explicitly mandate guy wires in all situations, it emphasizes the importance of substantial and secure installations as outlined in Article 810. This implies that the installation must be robust enough to withstand foreseeable environmental conditions. The utility company's decision likely reflects a more conservative approach to safety and risk management, prioritizing the prevention of potential hazards over strict adherence to the minimum requirements of the National Electrical Code. There are several factors to weigh when determining whether a guy wire is necessary for a mast installation. These factors include mast height, mast material, antenna size and weight, wind load, local codes and regulations, utility company requirements, and potential liability. Firstly, mast height is a critical consideration. Taller masts are more susceptible to wind loading and require additional support. A mast extending 3 feet above the roof is generally considered to be at a higher risk. Secondly, the material of the mast also affects its strength and stability. Rigid conduit is a common material for antenna masts, but its load-bearing capacity varies depending on its diameter and wall thickness. Thirdly, the size and weight of the antenna directly impact the stress on the mast. Larger and heavier antennas create greater wind resistance, increasing the risk of the mast swaying or collapsing. Fourthly, wind load is a major factor. Areas with high wind speeds require stronger masts and more robust support systems. Local wind speed data should be considered when assessing the need for guy wires. Fifthly, local codes and regulations may have specific requirements for antenna installations, including the use of guy wires. These codes are designed to ensure public safety and prevent property damage. Sixthly, utility company requirements must be followed. Utility companies often have their own standards for antenna installations, particularly when the mast is connected to their power grid. Seventhly, potential liability is a significant concern. Homeowners and installers can be held liable for damages or injuries caused by a collapsing mast. The ANSI/GI 222G standard provides guidelines for antenna structure design and installation. This standard outlines the minimum requirements for mast height, material strength, and guy wire placement. It is widely recognized and used by antenna professionals to ensure safe and reliable installations. When considering alternatives to guy wires, increasing the diameter of the mast is an option. A 2-inch rigid mast would provide greater strength and resistance to bending. However, It is important to ensure that the mounting hardware is also compatible with the larger mast size. Another alternative is to use a different type of mast material. Steel masts are generally stronger than aluminum masts, although they may be more susceptible to corrosion. In situations where guy wires are not feasible, a self-supporting tower may be considered. Self-supporting towers are designed to withstand wind loads without the need for external support. However, they are typically more expensive and require professional installation. When installing guy wires, it is important to use the correct type of wire and hardware. Galvanized steel wire is commonly used for guy wires due to its strength and resistance to corrosion. The guy wires should be properly tensioned to provide adequate support without overstressing the mast. The anchor points for the guy wires should be securely attached to the building or the ground. Concrete anchors are often used for ground-mounted installations. The angle of the guy wires is also important. The guy wires should be spaced evenly around the mast and angled downward at approximately 45 degrees. This configuration provides optimal support and prevents the mast from swaying in any direction. Proper grounding of the antenna mast is essential for safety. The mast should be grounded to a grounding electrode system such as a ground rod or a metallic water pipe. This helps to protect against electrical surges and lightning strikes. The grounding conductor should be sized according to the National Electrical Code. Article 810 provides specific requirements for grounding antenna systems. Regular inspections of the antenna mast and guy wires are recommended. This helps to identify any signs of wear or damage. Loose or corroded guy wires should be replaced immediately. Any cracks or bends in the mast should also be addressed promptly. In conclusion, the decision of whether to use guy wires or a larger mast depends on a variety of factors, including safety concerns, structural integrity considerations, liability risks, and code compliance. While the electrical inspector initially approved the installation without guy wires, the utility company's requirement for guy wires reflects their own safety standards and liability concerns. The ANSI/TI-AMINA's 222G standard recommends the use of guy wires for masts that are 3 or more above the roof and 6 or more from the edge of the roof. Based on these factors, it is generally recommended to use guy wires for the installation of the 1.25-inch rigid mast as required by ProCo. This will provide additional support, reduce the risk of the mast collapsing or swaying, and ensure compliance with industry standards. If guy wires are not feasible, a larger mast or a self-supporting tower may be considered. However, these alternatives should be carefully evaluated to ensure that they provide adequate support and meet all applicable codes and regulations. Proper installation and maintenance of the antenna mast and support system are essential for safety and reliability. It is recommended to consult with a qualified antenna installer to ensure that the installation is done correctly. The National Electrical Code and the ANSI/TI-AMINA's 222G standard provide valuable guidance for antenna installations. Following these guidelines will help to ensure a safe and reliable antenna system. When determining the appropriate size of the grounding conductor, refer to National Electrical Code Table 810.16. This table provides the minimum size of the grounding conductor based on the size of the antenna lead-in wire. The grounding conductor should be connected to a grounding electrode system that meets the requirements of National Electrical Code Article 250. Common grounding electrodes include ground rods, metallic water pipes, and building steel. The grounding electrode system should have a resistance to ground of 25 ohms or less. This can be verified by a ground resistance test. Proper bonding of all metallic components of the antenna system is also important. This helps to prevent voltage differences between different parts of the system. Bonding conductor should be sized according to the National Electrical Code Table 250.102. All connections should be made with approved connectors and fittings. The installation should be inspected by a qualified electrical inspector to ensure compliance with all applicable codes and regulations. The inspector will verify that the mast is properly supported, grounded, and bonded. Any deficiencies should be corrected before the antenna system is put into service. Regular maintenance of the antenna system is essential for long-term reliability. The mast, guy wires, and grounding system should be inspected annually. Any signs of corrosion or damage should be addressed promptly. The antenna connections should also be checked to ensure that they are tight and secure. The antenna system should be protected from lightning strikes. A lightning arrestor should be installed on the antenna lead and wire. The lightning arrestor should be grounded to the grounding electrode system. This will help to protect the antenna system and connected equipment from lightning damage. The antenna system should be installed in a location that is free from obstructions. Trees, buildings, and other objects can interfere with the antenna signal. The antenna should be mounted as high as possible to improve signal reception. The antenna should be oriented in the direction of the desired signal source. A signal meter can be used to optimize the antenna position. The antenna system should be properly labeled. The label should identify the antenna type, frequency, and grounding information. This will help to facilitate future maintenance and repairs. The homeowner should be educated about the proper use and maintenance of the antenna system. This will help to ensure that the system operates safely and reliably for many years. The information provided in this narration is for general guidance only. It is not intended to be a substitute for professional advice. Always consult with a qualified antenna installer or electrical contractor before installing or modifying an antenna system.